Welcome, everybody. This is SEMA Central, the 2014 SEMA show, right here live at the Las Vegas Convention Show. And it is Rob Prucka sitting next to me, a professor at Clemson University, which means if you compare the size of his head to my head in the brain pan, mine's about that big, and yours is about this big, man.
Sure.
No, and
I don't believe it.
I got to loosen you up here.
Sounds good.
One of the professors that really does take the interest in my mind, filling the pipeline with young people that can become engineers, builders, innovators in this industry. So tell us about what you got going on over there.
So at Clemson University, we have an automotive engineering program. We have about 220 students. And what we're doing here at Clemson is, you can see the MSD Corvette over here. We help automotive aftermarket companies design and build products and help them pass emissions. So as part of that process, we educate students and hopefully send them into this industry in the long run. So.
Well, a lot of it is, it's always a common referred to phrase as reverse engineering, because you look at what the OEs do with the C7 Corvette that you have over here, or any of the other, say if it's a Challenger or a Mustang, you guys have to then take what they've spent millions of dollars and millions of hours to develop to then let people have the opportunity to make it better. So talk about that process.
Sure, so we instrument vehicles with hundreds of thousands of dollars worth of equipment. Okay, it's a complicated process. And we try to understand, okay, what is this new product? What is special about this new product? Why is it different? For example, a Corvette is now direct fuel injected. It's a challenging new technology to deal with. So we instrument the vehicle around that and try to understand and characterize that capability of the engine. So we instrument everything we can on it. We record just gigabytes and gigabytes of data over several minutes, or we do entire drive cycles. And then we develop data processing routines that translate that data into something useful for SEMA members.
It's almost, it's like doing 1,000 dyno runs without doing 1,000 dyno runs.
You got it, yeah. In several minutes, we can identify quickly where there's a problem area for emissions or combustion or some engine calibration, whereas that could take, in a trial and error process, it could take months or years to do. Normally, you can usually do that within minutes. So.
With your capabilities, and you said you're an engine guy, and I love that, with your experience and what you do as a professor, you look back even 15 years. Fuel injection was scaring half the people in this building. Now we're looking at direct injection. They're looking at different valve train capabilities, pneumatic valves. In your mind, where do you think, this is your crystal ball we want to look through. Where are engines going? Because technology is not going like this. It is ramping and going straight up.
Straight up, for sure. The big challenge in the industry is by 2025, they have to meet an average of 54.5 miles per gallon on average. So it's really, really challenging. So to me, I think what it looks like is happening, at least until 2020, is you're going to see sort of more conventional is the wrong term, but gasoline engines with multi-speed transmissions will make us to about 2020. Then after that, it's going to be a lot of electrification probably. And then the challenge will be, you'll still have probably a gasoline engine on board, but you'll have some hybridization. But then to figure out, well, will we go to diesel engine only? Will that be less expensive than doing gasoline with hybridization? And then I think if you look at it, you ask a lot of the OEs right now, they're trying to develop what they call lean burn, turbocharged, downsized engines right now with multiple EGR loops. And the challenge for this industry is that those engines are much more complicated. They have more knobs that you can turn at any speed and load. So even at idle, for example, on this car, you probably have 300,000 different options just at idle of where you would set all the actuators. And you have to try to identify which is the best one, and that's difficult. On these new engines, you're going to have millions of options. And it makes it a little bit harder for this industry, but you just need top quality equipment to be able to understand what these technologies are, and that's what Clemson provides, and that's what the SEMA Garage is providing as well.
Amazing facility, too, by the way. Where do you think that will roll into the performance end of the industry? Because there's still going to be horsepower junkies like me that want to go fast.
Me too.
And I know that whether we want to or whether we're reluctant to, we're going to have to adapt technology. There was a time when people had pagers and they said "baha" to the internet. But technology is going to change. How will that affect the performance arena, especially at a place like here?
I think it's going to make it stronger. It certainly presents a lot of challenges, but I think it also presents just as many opportunities. When you push for fuel economy, which is what they always have to do now, it may open the door for some more performance, actually. So you can imagine some SEMA member companies that can actually convert over and try to take those cars and make a lot more performance out of them. There's a lot more window maybe there than even there is today. especially when you look into hybrid powertrains. They don't sound very exciting in what you see on the road today, but an electric motor has a high amount of torque, and you can make a really great hot rod with an engine and electric motor combined. And so I think that you'll see that slowly penetrate into this market. It's not going to be as fast as it is in the everyday passenger cars, but I think you'll see it here, and it'll actually make everything faster, which is hard to complain about.
Well, faster's always better, but it's just,
right.
it's like I said, that's going to be, it's a strange time we're in. Not a bad time. No. It's just kind of it's a strange time because there's it's a new path.
Yeah.
There is no fate, but where they're going to take us. So it's amazing where technology will take us.
Yeah. We don't have any choice. We sit there and watch it in some way, but try to react as fast as we can in this industry. And as a professor, we are always staying ahead. We're also helping the OEs move forward and what they're doing in their next steps too. So we see sort of both sides of the equation, and it's not going to stop anytime soon, and it can't, because we have these really strict regulations coming up that we have to meet, or they can't sell vehicles. So that's not going to happen. So we have to get used to it and just keep moving forward and educating ourselves as much as we can.
Well, it'll be crazy. It's 2014 now. Maybe by 2024, you and I will be having this conversation. It will be a different conversation for sure.
I hope so. I hope everything works out really well, and I'm sure it will, actually.
If people want information about what you're doing at Clemson or how to get involved with the programs, how do they do that?
Just CU-ICAR.com.
Excellent.
It's the fastest place.
Well, thank you so much for coming up here to SEMA Central. More from SEMA 2014 right here at the SEMA Central stage. We'll be right back.